In this video, we're going to create a number guessing game in C. The user is going to be asked to guess a number between 1 and 100, and we'll have the program tell the user if their guess was too high, too low, or if they've guessed correctly. The first thing we'll do is declare an int type variable called number to store the number itself. We'll initialize this variable to 37 for now, but what we'll eventually do is randomly assign a number between 1 and 100 to this variable. We'll also declare an int type variable called guess to store the user's guess, and we'll initialize this variable to 0 for now. Then we'll prompt the user to enter their guess. So we'll call printf, and we'll pass it the string \n for new line, and then enter your guess : to prompt the user to enter their guess. Then we'll call scanf to accept the guess from user input. So we'll call scanf, and we'll pass it a string with %d to accept an int from user input, and then we'll have and guess as the second argument to pass the memory address of this guess variable to the scanf function, so it can store the entered guess into this variable. Then once we have the guess, we'll check to see if the guess is greater than the number, or less than the number, or equal to the number. So we'll have here, if the guess is greater than the number, that means the user guessed too high, and we'll output that. We'll have here call to printf, and we'll output \n for new line, and then too high, ! \n. Otherwise, with an else if branch, we'll check to see if the guess is less than the number. So if the guess is less than the number, this means the user guessed too low, and we'll output that. So we'll call printf, and we'll have \n, and then too low, ! and \n, and semicolon. Otherwise, the only remaining possibility is that the guess is equal to the number. In that case, we'll output that the user guessed correctly. We'll have printf and \n, and we'll have congratulations, ! \n, and we'll call printf again, and we'll say, you guessed the number. And we'll have \n again. So if we save this and then compile the program, and then we'll try it out here, we know the number is 37. So if we enter in 42, we'll get here too high. If we enter in 35, we'll get too low. And if we enter in 37, we'll get congratulations, you guessed the number. So the program is working right so far. Now, what we would like to do is have the user repeatedly guess until they get it correct. So let's do that. Now, in order to do that, we're going to have this code here execute multiple times, where the user can repeatedly enter in a guess and then get feedback on whether it's too high, too low, or whether they got it correct. And once they get it correct, we want to stop this process, because once they've guessed it, the game is basically over. What we can use here to repeat the execution of these statements is a control structure called a loop. A loop can repeat the execution of a block of code. And we're going to use a loop called a while loop. So here, we'll create a while loop, and this while loop is going to have a condition here. The condition is going to be determining whether the loop continues or not. In other words, whether this block of code here is going to execute or not. And so long as the condition we put here is true, this block of code is going to execute again and again. Once the condition we put here is false, then this block of code will cease to execute, and whatever statements are after this while loop will then execute. So we'll cut and paste this code here, and we'll put it inside this while loop block. So we'll take all this code here, and we'll cut it, and we'll paste it, and we'll put it in here. And I'll just tab it over again to make it clear that this code here is part of this while loop block. So this code here is going to continue to execute again and again until whatever condition we put here is no longer true. Now, what I'm going to use for condition is while the guess doesn't equal the number. Because if the guess doesn't equal the number, what that means is the user has not correctly guessed the number so far. Once the guess does equal the number, that will mean the last entered guess was the correct guess because it's now equal to the number. Now initially guess is set to 0. So initially, guess is not going to equal the number. And this here, exclamation mark equals, this here is checking to see if the guess doesn't equal the number. This operation here is the does not equals operation. It's going to be true so long as the guess doesn't equal the number. If the guess does equal the number, this operation is going to return false, and this condition is going to be false, and this loop is going to stop. So now let's try our program out. We'll save it, and then we'll compile it, and then we'll run it. So now I'll enter in 42, and it says too high. So I might guess something lower, like 25. Now it says too low. So now as the user, I know the number must be between 25 and 42. So I might guess 35. Now it says too low. Now I know it's between 35 and 42. So I might guess 40. And I'm told it's too high. So now I know it's between 35 and 40. And now let's say I guess correctly that it's 37. And I get congratulations, you guessed the number. So now we have a real game here. And again, the user is being prompted to enter a guess and then being given feedback again and again because of this loop here. Because this loop is going to run again and again so long as this condition here is true. Now, once this condition is false, execution is going to jump down here below this while loop body, which is closed with this closed curly brace here. So here, for example, I could call printf and I could thank the user for playing. So I could call printf and I could have \n and then thanks for playing, !n. And this will execute then once this while loop is done. So if we save it and compile it and give it a try now, if I enter in 41, it's going to say too high. I'll enter in 37. Now it says, congratulations, you guessed the number. And then we get thanks for playing. Another thing I may want to do to make the game more challenging is give the user a limited number of guess attempts. Let's do that. We'll declare an int type variable called attempts. And this variable is going to keep track of how many guess attempts the user has made. So we'll have int attempts, and we'll initialize this variable to 0 because initially the user hasn't made any guess attempts yet. Then we'll also declare an int type variable called max attempts. And this variable is going to keep track of the maximum number of guess attempts that the user is allowed. And we'll allow the user to have 6 attempts. So we'll initialize this variable to 6. Now here, because this variable has 2 words, what I've done is used an underscore to separate those words. This is called snake case, and it just makes the variable easier to read. Now what we'll do is every time the user makes a guess, we're going to increment attempts by 1. So we'll add 1 to attempts to keep track of how many guesses the user has made so far. So here, after we input the guess from the user, we'll increase the value stored in attempts by 1, with attempts is equal to attempts plus 1. What this will do is add 1 to attempts and store the resulting number back into attempts. In C, there's a short form for doing this because this is such a common operation. We can use here the postfix increment operation with attempts plus plus. What this will do is add 1 to attempts and store the result back into the attempts variable. And that is sort of a short form way of doing that in C. Now, because attempts is increasing by 1 every time this loop body runs and the user enters in another guess, what we want to do is stop this loop once attempts reaches max attempts. So long as attempts is less than max attempts, we want to continue this loop. But if attempts is greater than or equal to max attempts, at that point, we want this loop to stop. What would be nice is if we could have a second condition here. And the second condition could be attempts is less than max attempts. Because what we want to do is continue this loop so long as attempts is still less than max attempts, knowing that it's increasing by 1 with each loop iteration. This here is the less than operation, and it's comparing attempts to max attempts. And it's going to return true if attempts is less than max attempts and false otherwise. Now we actually could have both these conditions here if we use the AND operation. So what I could have is guess doesn't equal number, and then ampersand, ampersand, and then attempts less than max attempts. This here is the AND operation. What it's going to do is return true if this is true and this is true. Otherwise, it's going to return false. So this means this loop is only going to continue running if this condition that the guess doesn't equal the number is true, and this condition that attempts is less than max attempts is also true. Let's save a program and compile it and try it out. So we'll compile it and we'll run it, and I'll enter in 1, 2, 3, 4, 5, 6. And now we see the user does have 6 guess attempts total before the game stops. Let's actually tell the user when the program first starts how many guess attempts they have. I'll also output a game title. So up here we'll call printf, and I'll pass it a string with a new line to start, and then we'll have 10 stars here, and I'll call it guessing game. Then I'll have another 10 stars here, so I'll copy these and paste them, and I'll have a new line there. And then we'll tell them they're guessing a number between 1 and 100. So we'll say, I have selected a number between 1 and 100, followed by a new line here. Then we'll call printf, and we'll tell them how many guess attempts they have. So we'll say, you have %d to output the number, attempts to guess it, followed by a new line. And this %d here means that printf is going to expect a second argument, which is the value it's going to place here when it outputs the string. And we'll pass in max attempts because that variable is storing the maximum number of guess attempts the user has. So we'll save this and we'll compile the program and try it out. And now the user is told you have 6 attempts to guess it. We'll input 1, 2, 3, 4, 5, 6. And again, the user has 6 guess attempts. Next, let's modify the game to tell the user how many guess attempts they have remaining after making each guess. So down here at the bottom of the while loop body, what we'll do is output how many guess attempts they have remaining. So we'll call printf, and we'll output you have %d for the number, attempts left, followed by a new line. And what we'll output is max attempts minus attempts. So this is the subtraction operation. And what we're going to have here is an expression, max attempts minus attempts. And the result of that expression is going to be passed as an argument to printf. And that resulting value is what's going to be output here. Let's try it out. We'll save the program and compile it and run it. I'll enter in 1, and we get you have 5 attempts left, which makes sense. And we'll have 2, you have 4 attempts left, 3 attempts left, 2 attempts left, 1 attempt left, and then finally you have 0 attempts left. In this case here, where the user has 0 attempts left, they've essentially lost the game at this point. So let's actually output a special message in this case, and we'll tell them what the correct number was. So we'll go back to our code here, and I'm actually going to have an if statement here. I'm going to say if attempts is equal to max attempts. So if this is true, this means the user is now out of attempts, and they've essentially lost the game. So in this case, we'll output using printf, you've used all %d attempts, where %d is going to be replaced with max attempts. So we'll remind them how many attempts total they had. Then we'll also output here the correct number was, and then %d for that number, followed by a new line, and we'll output the actual number itself. Then we'll output an encouraging message. We'll say, better luck next time, followed by a new line. So if attempts reaches max attempts and they've essentially lost the game, we're going to output this content here. Otherwise, we'll have an else branch. And inside that else branch, we'll output this message regarding how many attempts they have left in that case. So it's going to be one or the other. If they have attempts remaining, we're going to output this message here. If they have no attempts remaining, we're going to output this content here. So we'll save it and compile the program and try it out. I'll put in 1, 2, 3, 4, 5, and we see we're getting the message as expected. If I put in 6 though here now for the last attempt, we now get you've used all 6 attempts. The correct number was 37. Better luck next time. If they do guess the number correctly, let's also tell them how many attempts it took them. So in that branch here of this if, else control structure, let's say how many attempts it took. So we'll say you guess the number in %d for the number attempts. And we'll output the number of attempts it took by supplying attempts here as a second argument. So now if we save it and compile it and try it out, I'll enter in 50 for one attempt, then I'll enter in 37. And it says here, you guess the number in 2 attempts, which is correct. Now, because we're storing the maximum number of guess attempts in the max attempts variable, we could always change that by altering the program. So if, for example, we want the user to have 7 guess attempts, we could change max attempts to be initialized to 7 here. And we can save it and compile the program and try it out. And now the user is going to have 7 attempts. And we could put in 1, 2, 3, 4, 5, 6, 7, and the user now has 7 attempts total. When we change the value of a variable like that in the source code, we call that a compile time change. What that means is it's a change we made before we compiled the program. Other variables like attempts here are being modified at what's called runtime or execution time, where attempts is being incremented with each iteration of this while loop as the program is running. Now, notably, max attempts is not being altered at runtime. We set it to 7, but then after that, it's never altered again. We use it in comparisons like this, we output it, and we use it in expressions, like down here, when we have max attempts minus attempts. But we never actually modify the value that's stored in max attempts at runtime, or what's called execution time, as the program is actually executing. So this variable is essentially a read-only variable, where we just set it to one value and then we use it in our program. We can actually make this what's called a constant variable in C. So up here, I'll have const int max attempts. And what this does is it makes this variable read-only. So we can only set it to one value, and then we can't modify it afterwards. So here we set it to 7, and we can't modify it later on. We can still use the variable in a read-only way like we are already, but we can't modify it later. The reason why we might do this is because if max attempts were ever altered in our program, that would be a mistake. That variable should not be altered in our program. And if we did that, it would be a problem. The compiler could then flag this problem for us by giving us an error message. So for example, if we did set max attempts to 7 as a constant variable, and then later on, we tried to increment max attempts with max attempts ++, here, we're actually trying to modify the value that's stored in this variable. And because it's a constant variable, we can't do that. Let's try it. We'll save it, and we'll try to compile the program. And we'll get here an error. It says error cannot assign to variable max attempts with const qualified type constant. So we can't modify it after this one initialization here because it's a constant variable. So let's fix that error now. We'll delete this here. And I'm actually going to set max attempts to 6 again to make the game more challenging. Now, another issue with our game is that if the player takes as many attempts to guess the number correctly as they have attempts total, they're going to get some confusing output. Because on the one hand, they're going to be told, congratulations, you guessed the number in this number of attempts. On the other hand, because attempts is equal to max attempts, they're going to be told the correct number was this number and better luck next time. So let's fix this. What we'll do is first test it out. We'll save it and we'll compile it. And we'll run it. And let's try to guess it correctly in 6 attempts. So I'll put in 50, too high, so I'll say 25, too low, so I'll say let's say 36. Too low, so I'll say 42. Too high, I'll say 39. And then I'll say 37. And here we get it correct. So it says congratulations, but it also says better luck next time. So let's fix this. Now the way this loop is going to run currently is that this entire block is going to execute before this condition here is checked again. And when this condition is checked again, we're going to see that the guess does equal the number in that situation, and then the loop is going to stop. What we want to do though is stop the loop right here after we've recognized that the user has won. What we could do is use what's called a break statement. So here I'm going to have break and then semicolon. This is a break statement in C, and what it will do is stop the loop right here. So in the situation that the guess does equal the number and this else branch executes, we're going to output congratulations and you guess the number. Then this break statement is going to execute and the loop is going to stop. And we'll output down here, thanks for playing, after the loop body here. And that's it. Now what we can do is also take out this part of the condition. So we'll just check that the attempts are less than the max number of attempts, and that's it. So now we'll save it and try it out. So we'll compile it and run it. We'll enter in 45 and 25, and then maybe 39, then maybe 28, then 33, then we'll guess correctly 37. And now we just get congratulations, you guessed the number in 6 attempts, and that's it. And what happened was, once that break statement executed, the loop stopped at that point, and the rest of the loop body here is essentially skipped over, and then execution is going to resume down here with this printf. Now currently, every time the program runs, the number 37 is the number the user has to guess. To make this program more interesting, what we want to do is randomly select an integer in the range of 1 to 100. We can do that. So right now, we're including this library, stdio.h. And that library allows us to use functions like printf and scanf because those functions are defined in that library. There's another library called stdlib.h. We'll include that library too. So we'll have # include stdlib.h. Now this stdlib.h library, along with the stdio.h library, are part of what's called the C standard library. What that means is that we can just include these libraries and we can expect them to be there as part of C. Now this library includes a function called rand, and the rand function can provide us with a random integer. So here we can call rand. And what we're doing is calling rand, like how we're calling printf here. But the rand function does not accept any arguments, so we have no arguments. Now the rand function is going to return a value. What that means is that at runtime, when this function executes, as our program is executing, this function call here is essentially going to be replaced with an integer value that this function is going to provide. And we say the function returns that value. So here, when we call rand, it's going to be replaced with a random integer. And we know that integer is going to be in the range of 0 to some very large positive integer, because that's how the rand function is defined to work. Now, we don't exactly know what this positive integer is. It's actually defined by something called rand max. But for our purposes, let's not really worry about that. We just know it's a very large positive integer. And we know that rand is going to return a random integer in the range of 0 to that very large positive integer. Now to actually take that integer and put it in the range of 1 to 100, we're going to use an operation called modulus in C. So the modulus operator is the percent symbol. And what this does is it returns the remainder of a division operation. So to make things a little simpler, let's first look at dividing integers in the range of 0 to some very large positive integer by 3. And we'll look at the remainders we get back. So for example, if we have 0 divided by 3, what that's going to give us is 0, remainder 0. If we have 1 divided by 3, what that's going to give us is 0, remainder 1. If we have 2 divided by 3, what that's going to give us is 0, remainder 2. Then if we have 3 divided by 3, we're going to have 1 and remainder 0. And then 4 divided by 3 will give us 1, remainder 1. And then 5 divided by 3 will give us 1, remainder 2. And then finally, 6 divided by 3 will give us 2, remainder 0. And we could keep going up here, but this pattern is just going to continue, where if we take this integer in the range of 0 to some very large positive integer and divide it by 3, we know the remainder is going to be in the range of 0 to 2, because that's really the only possible remainders if we take a number in that range and divide it by 3. Now, in the same way, if we take an integer in this range and divide it by 100, the only possible remainders are 0 to 99. So let's do that. What we'll do is we'll take the integer that's returned by rand, and we'll divide it by 100 using modulus. Now, what modulus is going to give us is the remainder. So we're basically going to take the integer in this range here and apply a division of 100 operation using modulus. And because we're using modulus, what we're going to get back is a remainder. And we know that remainder is going to be in the range of 0 to 99. So we're pretty close. This will give us an integer in the range of 0 to 99. What we need is an integer in the range of 1 to 100. So what we'll do is we'll just add 1 to this. Because if we take a number in this range and add 1 to it, that will put it in the range of 1 to 100. And that's it. So do that. We'll take this here and we'll add 1 to it. And that's it. Okay. So we'll save this and then we'll compile the program and try it out. So we'll compile it here and we'll run it. And I'll put in 50, too high, so I'll try 25, too high, so I'll try maybe 13, too high, so I'll try maybe 6, too low, I'll try 10, too high, so it's got to be 7, 8, or 9. Hopefully I get this here, so I'll say 7. And I didn't get it. The number was actually 8, and I've lost at my own game. The number was no longer 37 because we're now using that rand function to help us create the number. Let's see if it's different if we run the program again. So we'll try 50 here, and it says too high. So I'll try 25, and it says too high. I'll try 13 here. It still says too high. I'll try 5, too low. I'll try 9, too high. Let's try 8. Look at that. It was 8 again. So we seem to be getting 8 here. Let's try it again. This time I'll guess 8 right away. And again, we got it right. It was 8. Now the reason why that's happening is that C uses something called pseudo random number generation. What that means for our purposes is that we need to seed the random number generator with a different value each time our program runs in order to have the possibility of the rand function returning a different value each time our program runs. Let's do that. So to seed the random number generator, we can call the srand function. So we call the srand function. And this function is going to seed the random number generator. Now the idea is that we want to supply this function with a different value each time the program runs, because the value we supply this function is going to basically determine which random values the rand function returns. So for example, if I supply this function with the value 10, we'll very likely get a different random value back from rand. We'll try that. We'll save it, and we'll compile it, and we'll run it. And instead of starting at the middle with 50, let's actually try to put in 8, because we know we got 8 before. And it's not 8 anymore, so we know it's not the same number anymore. It says too low. We could try to guess it for fun. So I'll put in 50. Too low, I'll try 75. Too high, I'll try 65. Too low, and I'll say maybe 70. Too low, I'll try 73. and we didn't get it. It was 71, but it wasn't 8. Now, if I try it again, it's going to be 71. So I'll try it again, and it's going to be 71. I'll put in 71, and we get it. And what's happening here is pseudo random number generation, where the value supplied as the seed value to srand is determining what numbers rand is going to return. Now, if we can supply this function with a different value each time the program runs, then the random number we get back from rand when we first call it can be different each time the program runs. What we'll do is supply the srand function with the current time, because the current time is going to be different each time our program runs. Now, to get the current time, we can call a time function, and the time function is included in the time library. So up here, I'm going to include the time library with number sign include and time.h. Then down here, we'll call the srand function, and what we'll pass it is the value returned by the time function, and we'll pass the time function this special value in C null. Now, let's not worry about this special value in C null. That's a value that has to do with memory addresses and the concept of pointers in C, and that's covered in other videos on this channel. But for now, let's understand this. The time function is going to return the current time, and the current time is going to be different each time the program runs. So like how rand returns a value, time is going to return a value, and the value it returns is the current time. And the current time is going to be different by definition each time we execute the program, because time's always going forward. And then we're going to take that value and pass it to srand as the seed value. So the srand function is going to be given a different value each time the program runs, which will allow the rand function to return different values each time the program runs. Let's try it out. We'll save it, and then we'll compile our program, and we'll run it. And let's try 71. It's not 71. Let's try 8. It's not 8. So it's something different. Let's try 50 here. Says too high. Let's try maybe 27. Too high. We'll try maybe 16. Too high. We'll try 12. We didn't get it, but it was 15. It was something different. Let's try it again now. We'll run it. I'll put in 50. Too low. So I'll try 75. Too high. We'll try 63. Too high. We'll try 56. Too high. 53. Too low. So it's got to be 54 or 55. I'll try 54. And we got it. It was 54 this time. And we did beat the game. The number is different though. So it's different now each time we're running the program. Let's try it again. 50. Too low. So I'll try 75. Too high. So I'll try 63. It's too low. So we'll try 69, too low, 72, too high. So it's got to be 70 or 71. We'll try 70. And this time we didn't get it. It was 71. But we see now the number is different each time our program runs because it's being randomly selected between 1 and 100. Now, there are many more ways we could expand upon this program. One thing we could do is allow the user to select a difficulty level. So we could have beginner, medium, or hard. And maybe what we could do is increase the range of the numbers depending on the difficulty level they selected. Maybe what we could do is allow the user to enter in the range of numbers themselves. And we could modify our expression to account for that range. But these are the kind of things we could do to modify the game and make it something that's more our own. But this has been a fun little number guessing game in C. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.